Okay. Yeah, just to kind of concrete that introduction, my own background kind of starts with the internet, building early internet infrastructure in the 1990s. Voice over IP, I had a UK-based voice over IP company, and conversational AI really since the early 2020s. But most of the things I've been involved in are the idea of building code for infrastructure, because building stuff out is what I do and what I enjoy doing. The talk is going to be in 3 parts, so it really doesn't matter whether you don't know what voice AI is and what the engineering challenges are. If you want to know what the kind of the hard bits and the most recent bits are, and then somehow when I put the talk pricing in, I said I would talk about futures. So if you don't care about voice AI and you just want to know how it might affect you, for things like video streaming, then the last bit. So hopefully everyone should get a little bit out of one of the 3 parts of the talk. So that's by way of an apology for this first bit, which is, kind of voice AI 101. The problem really for voice AI is actually pretty simple, or it is with modern LLMs. It's effectively to take some voice from someone, however it arrives, through WebRTC or through SIP, somehow kind of inject the meaning of that into an LLM, because LLMs do all the things and fix all the problems, or create all the problems, depending on perspective. And then when the LLM gives you some output in its kind of native coding, turn that back into voice output and get it back across the network to the guy on the end. I mean, this is voice, right? It's not video. It's not, multi-megabits per stream or anything like that. So what could be hard about this? There are some challenges, particularly if you're using text models, which is all we had to start with. So when I first started playing, I've been doing sort of voice AI using the NLU stuff since, kind of 2020 timeframe. But when GPT first arrived, and kind of a few folks at the start of 23 thought, wouldn't it be kind of interesting if we just take these text mode LLMs and hook them up to voice conversations and they could do useful work for us? And I think what we discovered quite early on is that that's actually quite hard, because there's quite a mismatch between what a text mode LLM expects and what a human being expects from a conversation. So, text chat is delimited. I type something, I hit return. LLM sort of thinks about that. It gives me an inference back, and we kind of go in turns like that. There's no kind of misunderstanding of who's finished and who hasn't or anything like that. And synthesizing a turn-by-turn text chat for an LLM API is surprisingly hard. It's surprisingly hard to detect when I finish the segment of speech. So if we just go on delay, we'll do that wrong. We can do it on a semantic basis, but that's quite hard as well. So there are a number of techniques that we have to use there for voice activity detection. So that's kind of one hard bit that makes it not quite as easy as that last slide implies. We can bias it by previous utterance length. We've also got the latency implied. So effectively, where we've got this whole pipeline of voice activity detection going into an STT when we think we've got enough of a sample, and then chuck it at the LLM for some inferencing, get some TTS back, and then send it to the user. That's a multi-second process. That does not feel like a real conversation. That's, it's fine if you're talking to an AI and you're willing to walkie-talkie yourself. You say something, you wait for it to come back. You say something, you wait for it to come back. But it's not really great. Same thing for interruptions. There's a problem with AI starts talking and I'm impatient, so I talk over it, or it got the turn detection wrong, so I hadn't finished. And again, there are techniques to fix all these things. So if I get an interruption halfway through, or the LLM gets an interruption halfway through, then I kind of back off. I delete the last conversation turn because I've got control over all this stuff. And from there, we can kind of make the conversation at least give a semblance of being a little bit normal. So it is quite hard, but we do have all these solutions to kind of try and fix the problem. We have one I didn't mention, which is using pipelining for the latency. So we kind of start the output the moment we start getting tokens back, and we also do effectively prospective completions from the LLM. So we've got a bunch of things we can do here. I didn't actually even mention filtering. That's one of the problems, is kind of hallucinations and controlling the LLM output, which in some environments can be kind of really important. But the nice thing about this pipeline approach is we've got these pinch points where we can kind of fix these problems. So we've got a pinch point between the TTS engine where we can do turn unwinding text filtering pipelining and do the voice activity detection, and we've got another pinch point on the output filtering. So, you know, we can... People call these things guardrails. I really kind of hate that term because it's really just filtering, right? So effectively, we can do output filtering there because we've got the text in our hands. So, you know, if it's really important that our AI doesn't, you know, kind of swear at our customers or tell them to do inappropriate things, we can do really, really kind of gross, hacky, kind of algorithmic suppression of words in there. So we've kind of got to a point where, give or take the kind of latency, you've got some in there that certainly works in demo land. And we started building around this. Well, first of all, if you go way, way back, based on Asterisk plugins, Dan isn't even in the room, I don't think. Yes, he is. You remember that Asterisk plugin that you did with MQTT to coordinate, yeah, all of that stuff? So if you go back to sort of 2016 kind of time frame, that was quite a good way of doing things, or it was quite a way of doing things. When I came to revisit this in 2020, Jambones was there. David sort of moved Dractio into a kind of a proper formal project and company, so it seemed to make sense to use that. And it was actually quite good for architecting these pipelines because you could use the gather verb and the say verb, very, very telephony oriented, because under the hood is free switch. So it's, you know, very much a kind of telephony oriented solution, although you can now do WebRTC using a JavaScript SIP engine, but it's not, it's kind of, it's not as pure as a WebRTC solution, but who cares? You know, if your target is telephony, that's not a bad way of doing that. So that was how we started building pipelines, and you know, it certainly worked for some applications. Sorry, my phone notifications are on because I'm going to do something with that in a minute, so I can't actually turn them off. And one of the things that we kind of established quite early on is that actually putting an orchestration layer on over the top of it where we can specify what all of the things that you need to do to execute an agent right at the top, and then the actual technology you use to implement it is kind of dependent on what you're driving out of the JSON file. So you can see here, this is a particular agent. This is a real agent here. The only bit that is not real is the redaction of my mobile number out of it. But you can see we're kind of specifying here that we're using a model of LiveKit front end, which I'm going to come on to in a second, and then Ultravox, which is a sort of open source speech-to-speech model based on Llama 70 billion. Okay, so that was quite important actually. So, you know, right at the start, we're doing this kind of thing as an orchestration layer, and what it's allowed us to do is every single kind of new technology that's come along, we just drive it from this JSON file, implement it in the underlying layer, and if you want to give a new model kind of a go with your agent, you just kind of run it, change the model string, and off you go. Okay, so come back to this Ultravox thing that we saw in there. So about this time last year, actually, I think I was talking here. And OpenAI had been sort of talking about doing speech-to-speech in their advanced voice, in their app. They had a direct speech model, but no one had released it as an API. So I think Ultravox were the first commercially released speech-to-speech model. If you know different, then feel free to abuse me afterwards, but I think that's the case. And quite quickly, we kind of demoed that, and we just put it underneath that JSON format. And I think I did a demo of it at exactly this event last year, because they'd only released it kind of end of August in kind of trial. So we got on that and had to play with that, which was quite interesting and quite nice. Quickly after that, we backfilled that with Jambones. So using Jambones as a carrier to get a WebSocket into, so you get a number that comes into Jambones. That gives me a WebSocket, so I can use Ultravox's WebSocket interface, so I can use their own WebRTC interface which actually at that time, and I think still is, was based on LiveKit. And then I can use the WebSocket interface using Jambones. Because if you want to build on open source, like a lot of people, almost universally in the voice AI space, the first release says, yeah, you can do telephony, just go to Twilio, type this in here, and that'll cause a WebSocket to appear over here, and then, hey, we do telephony. That's fine, and you know, Twilio did some quite useful things, which I'll kind of come back to, but I kind of wanted to build it from first principles to understand how to actually make it work. And this is kind of what we ended up with by that point. So, you know, this is the kind of the first third. I'm not going to dwell on this because it's a diagram that I used last year, but basically we've got kind of an orchestration thing, and we've got SIP carriers coming in, and we've got a whole bunch of different workers with Ultravox, LiveKit, LiveKit Real-Time, and Jambones, and then I think about 20 different models sitting out behind it. Gosh, I didn't kill the microphone, that's good. So the only problem with that is that WebRTC is a little bit clunky. So we had WebRTC for Ultravox, but I really wanted a good way of doing WebRTC. So there are a couple of options there, both really good, LiveKit and PipeCat. I know Dan talked about PipeCat yesterday. I've played with them. I think they're great, but I'm allergic to Python in deployment. It gives me headaches and spots. So I prefer to deploy other things other than Python. I mean, you know, for building stuff, it's great. For things like the global interpreter lock and stuff, the performance headaches that I have personally found, and it might be because, you know, I'm not smart enough, but I've found deploying Python at large scale to be problematic. I know the AI guys love it because you can chuck use arrays around in a timescale where JavaScript would still be garbage collecting something, but hey. So what we ended up with was this kind of scale deployment scenario where we've got a number of provider trunks. The SIP comes into Kama-Elio, which is configured through our own orchestration layer, so we have lots of numbers across multiple SIP providers. We desperately try and stay out of the media streams, right? Because if I'm buying LiveKit to do this, the full fat LiveKit, now that they've launched their own agent workers, is kind of like about 1.4 cents a minute. If I'm paying them 1.4 cents a minute to deal with my media streams, the last thing I want to do is bring them into a proxy and pay for that bandwidth again on my own platform. So far, we've got away with it, but I think at some point we're going to end up with a back-to-back user agent in there. And then we've got a React-based widget on this side over here that just encapsulates the whole thing. So, you know, React call starts by making a call on our infrastructure, which then nails up a LiveKit room, media to the LiveKit room. SIP call coming in does a very similar thing. Kama-Elio is not, it's actually a set of database tables that are built. So that tells the call, and actually there's a missing line there. So there's a SIP line between Kama-Elio and LiveKit. That tells LiveKit one instance to go to. So we end up with some quite useful stuff like this. And I pray to the gods of demos for something that I only wrote last night, actually, after the boat. Can we have some audio, please? Super. Can you help me? I'm trying to reach someone in the accounts department. Can you help me? Try again.
Try to help with general queries, but for...
Plug the audio and it works properly. Yeah, I'm chasing an invoice, actually. I don't know if you've got anyone there that can help me with it.
I'm going to go ahead and try to transfer you to someone in accounts who can help with your invoice query. Is that okay with you?
Yeah, go ahead. Really like to speak to them. Thank you. Hi. Oh, I know who they are. Could you tell them we're doing the invoice run on Friday and we'll send them an email? I really don't want to talk to them now.
I've gone back to the caller. They were trying to get help with an invoice. I spoke to the accounts department and they said they're doing an invoice run on Friday and will send you an email then. Is there anything else I can help you with?
Okay, so I mean, you know, that's a bit unfriendly. You wouldn't necessarily architect it like that. But that ability to take a call that's come in as a WebRTC call on a website, do some smart things stuff to gatekeeper it, and then turn it into an audio call if I have to, seems like kind of a cool feature for SMEs, right? I certainly kind of base that on something that I would like. Okay, let's go back to here. No, that was the video that I'm not going to use, just in case the demo didn't work. So, I mean, in terms of how we implemented that, it's all done inside a LiveKit room. We provide a set of functions to the agent, so the agent can use those. And if I pop back to here, I can yeah, okay, so, I mean, that's kind of what the JSON looks like for this. So we give it a bunch of functions, one to start a transfer, or one to do a blind transfer, one to do a start. No, sorry, in this case, it's only got the three. Start the transfer, transfer, finalize, and transfer, reject. So we're kind of leaving it to the LLM to do some stuff there. And in the real world, the prompt would be like 10 times this size, and you would gate it with functions because you would make it check that it was doing the sensible thing before it went off and did it. Okay. I think that's, kind of where we are now in terms of reasonable state of the art with large language model as telephone agents. When I put this talk in, I said, I'll do a bit about the futures. I'll, kind of tell everyone what's going to work. That's incredibly pretentious because, my take is that if you want to know what the future is going to be, don't ask a technologist, and I'm just a coder. If you want someone to implement the future, don't ask a politician. But I'm going to kind of do this anyway. So I'm sorry that you're victims of this. I've had quite an interesting couple of weeks. I found this on LinkedIn, and I'm sure Sandro will talk about this a bit later. So there was just this thing where a bunch of people, I think they were all resellers of a particular voice AI company, had all been hit because they put these forms on their website going, check out our AI, type in your phone number here. And lots of people went and typed in all these premium rate phone numbers and called them, and I got done for $600. Oh, I lost 18,000. People made videos about it. A guy made a video saying I lost. He didn't lose 18,000. That's clickbait. But that's there. So one thing that I took away from this is that there are literally the comments on that LinkedIn thread is there are lots of people coming into this space who some of them have very good ideas. And there's a lot of immaturity in the space that we've got to build architectures to actually kind of make safe for these folks. Another kind of observation about futures is the idea of adversarial communication that serves only to generate tokens. And thanks to him for this. I think he found this the other day and posted it somewhere, and I stole it because it was a good one. So this is an example of an AI outbound caller being filtered by an AI, and I'm sure they're both owned by Google, and Google is charging both parties to get rid of that call. That isn't a future that I think is particularly useful and wholesome. So I think some bad stuff will probably happen. I was really glad I came here. Because, listening to Simon Dehaene yesterday about the stuff with WhatsApp for healthcare in Africa, that's the stuff that we should be trying to build. And as a community, if we're architecting stuff for kind of good outcomes and making sure our architectures, kind of mitigate towards those good outcomes, I think that's going to be something where we help rather than hinder society in building some of this stuff. Speech to speech, how much time have I got? Oh no, I'm minus 1.5 minutes. Speech to speech, where's this going? Because there are a whole bunch of people that have invested in pipelines, and they are saying, pipelines are brilliant. If you don't do pipelines, your AI will catch fire and everyone will, it will all be terrible. The ones that really know aren't actually saying that. They're saying speech to speech is the future, but we've got a little way to go in terms of the safety around it. Speech-to-speech, to me, overwhelmingly is going to be the end solution to this because it's the only technology at the moment that allows us to do that natural voice. And in fact, I can see us getting to a point with it. So speech-to-speech is where we're tokenizing the audio straight onto the input of the model. We're not turning it into text first, and that allows us to get all the nuance. And yeah, you can do sentiment analysis as a separate out-of-band signal, but that's not the same as understanding the difference between no and no. They're two different words. They mean different things. And a speech-to-speech model will get that. Sentiment may not. So speech-to-speech works, kind of, except where it doesn't. It's certainly got a much better ability to understand the intonation of the audio in. I've got a little story about this, actually. I was building an Ultravox Live Kit plugin, because I'm a reasonably incompetent coder, I got the audio sampling wrong. I took it from the wrong place. So I think I was feeding a 2400 hertz frames PCM into something that was expecting, it wasn't even a multiple, it was like 4000 or something, so I was feeding different stats into both ends. And I have a little test agent, which is, it does weather forecasts by doing a couple of function call lookups. So it asks you where you want the weather for, you tell it where you want the weather for, it gets you the lat long, and it tells you what the weather is in that location. It was all working brilliantly. Absolutely brilliantly. It would say, where do you want the weather for? I would say London. I would see it doing the function calls. It would give me the answer. The weather in London is 14 degrees. I wasn't getting a transcript out. I've screwed this up. My code is screwed up here. Why am I not getting the transcript? And I went and looked at it. I wasn't getting the Ultravox service delivers a transcript, but they put it through a different transcript engine because they're actually doing, speech understanding in the directly tokenized onto the Llama model, but people like to see what they've heard. I think they use DeepGram or something similar. And I was convinced there was a problem, maybe their service was, there was a problem with that or whatever, and I went and debugged it. And I went as far as listening to the actual audio, the large language model and the transcription we're hearing. Obviously, what it was a burst. So it wasn't even I was getting the frame wrong, the frame sizes were wrong as well. So there was, we were getting bursts of high-speed voice with a gap and another burst of high-speed voice. It was absolutely unintelligible to me. The AI, the model, understood. I said, London, please. So there's a whole load of risk around that, that we've got these things generating transcripts of what the transcript engine thought it heard. Just imagine an attacker goes and I say I want to transfer $300 out of my bank account, and an attacker just injects a little tiny bit of something that sounds like white noise on the line that says million. So my bank transfers 300 million, and I go back and say, what the hell are you playing at? There's the transcript. Look, I only said $300. That's a fairly gross attack, but I'm sure some stuff like that will happen. But my point is, the understanding of these engines, even with poor quality inputs, is really rather good, except when it isn't. I think it is going to be where things go, and it's in the interest of the model companies, because by bringing the TTS into the model, they can sell you the more expensive audio tokens, and more to the point, they can make you sticky on their platform. So, OpenAI have WebRTC. They've just done a really nice looking SIP, actually, but it's inbound only, and you will still need all that SVC around it. Ultravox, Gemini 2.5 Pro has got a voice model on it, and Amazon have got Nova Sonic. So, they're all... everyone is moving into this space. Did I mention that Anthropic are definitely doing something? So there'll be kind of an Anthropic audio input sometime soon, and I kind of know that externally, so it's not particularly kind of secretive about that. Okay, last thing, and this is the bit where if you're a video person and you're thinking, what's this guy doing at my conference? Why is he taking up so much of my time? I think generative video comes next. So it's quite niche-y now, but the idea of an avatar talking to you. So, we had me calling an AI there on a WebRTC session on my desktop, and carrying that traffic is no problem at all. But if a decent proportion of all the video traffic on the internet turns out to be point-to-point and individual, because it's coming from an AI towards an individual user, forget all the CDNs and all the SFUs and content distribution that we've very carefully put in place over the years. All of a sudden, we found the holy grail. We found the use for edge computing. I never thought there was one, but it turns out there actually is. And what that is putting GPUs out at the edge that we can talk to. I don't think it adds too much value, and people kind of laugh about it, but if you ask Adidas or, Schwartz Crystal or something, if it adds any value, going to the website and having a personalized, very coiffured assistant sell you a pair of expensive trainers or something, yeah, of course it's going to happen. It already kind of is, but scaling it is going to be kind of your next job, video guys, I suspect. So, that's me kind of done. Bunch of links there. AppleSA.com is the company that kind of built all this stuff. It is an open source project. It's not a kind of proselytizing open source project. You can find it on GitHub, github.com/AppleSA. Feel free to kind of take stuff from there. Use the orchestration there. I like building things like that because I can reuse it myself. Other people can reuse it. If you want to get me on chat, at rob@matrix.org. Rob@applesay.com is the work address. I've got a personal blog on Pickering.org, and there's a LinkedIn thing over there if you do LinkedIn. I think that's actually absolutely perfect timing.
We have plenty of time for questions. Let's kick it off with Saul.
Well, first, thanks so much, man. I remember our conversations from 2 years ago. You were right on the money. Took me a bit longer to figure it out. So everybody listen to this man. He's usually right. I wanted to ask a question about your, kind of two parts. Your thoughts on, one of the interesting things with the speech-to-speech is that other than Ultravox, there is just nothing else out there, kind of, I don't think.
OpenAI real time?
Yeah, but I mean on the open source domain.
Yeah, there isn't.
There isn't, and that's...
Well, no, that's not true. There are other smaller projects. It's not fair to say that. But the only people providing it as an open source project that you can go and buy from them as minutes are Ultravox, as far as I know.
Yeah, this was... I tried to keep tabs on the ecosystem a bit, but it definitely seemed like Justin Levin for OpenAI took a hit, and it was a lot slower. At releasing things. I was very happy to see that they finally released 0.6. So question number the first is, do you think that they would survive after real-time going GA and everything that OpenAI is doing? And then I tried the LiveKit SIP thing back when in its very inception. And it was like I couldn't really get it to work properly with a server that spoke honest to God SIP. Did it get better over time to where it's more, production ready?
Okay, I'll talk to the first one because that's really easy to put to bed. I really don't feel comfortable commenting on an individual company and whether they're going to make
That's
it
fair.
or not. People work there, and they're good guys. They're trying to do something useful, and that's kind of a good model. And hopefully they'll either make it or pivot. They've generated some good technology. They could have just been bought by OpenAI, I imagine.
Yeah.
Kind of this time last year, and then we wouldn't even be talking about this. So I'm quite pleased they have held out in a way. So that's my take on number one. Number two, sorry, remind me again.
So the LiveKit SIP support, you
Oh,
had
yeah.
it in your
Yeah,
slide. Like, what has your experience been with it?
Yeah, you can't just,
testing it out?
stick a trunk on the end of it. I can't just wire it up to a gamma trunk or something. You can probably wire it up to Twilio or something, because you do have to get the headers just right. And who would want to anyway? Do I really want to expose the domain of my LiveKit room to every hacker on the internet? So you're going to put an SBC in front of it. And yeah, it can be made to work. And of all the options, I quite like it because it is properly, truly open source. I can take all the components of that solution, and if I want to build it rather than buy it from them, I actually can. And Jambones isn't quite like that anymore, in some ways.
That's good to know. Thanks, man.
There is over question one over there in the back. Oh, Dan has already in the mic, so let's switch the...
Hello. That leads me on to my question, actually, about protection and SIP and all of that. We've been told for years that SIP, voice is dying. PSTN is dying. We're doing less and less voice minutes, et cetera, et cetera. Feels like that's not the case anymore because of voice AI agents. What's your one bit of advice to anyone that is building a voice AI agent from a telephony historic person? Not that you're old, but but someone that knows telephony.
As an old person, what do you recommend an old person does? Okay. I think actually, if you know telephony, you're in quite a good place because you wouldn't have put a number on your website, a box on your website that says, enter a phone number here and I'll call it, right? So I think there are some advantages to being a bit old school telephony in this space because it allows us to, we understand all of the kind of all of the pitfalls that that have existed since before some 20-year-old kid that just discovered OpenAI real time was born, actually, which is scary, isn't it? So I think there are some advantages if you're an experienced telecoms engineer. But then again, you don't know a load of the AI stuff. And there is this gap between, I've got this old-fashioned UDP trunk that hasn't changed in spec for 20 years over here, and I've got this OpenAI real-time thing here, and it wants to do TLS, and, it needs the headers in a very specific format, and you've just got a massive gulf between those two. So I think learn AI is the advice that I would give them. And, to the folks who are building telco services and don't understand it, learn telco.
But that's really challenging.
We should go out and help them.
We should.
Right?
We should.
Lots of blog posts, lots of videos or whatever.
So I wanted to ask a question about the real-time, like speech-to-speech models and on their pricing, because I tried them out, but the pricing seemed to me like quite blurry on like how audio tokens are counted in and out. And then to me, it seemed quite expensive. And a few months ago, I made a calculation and told a couple of customers that, okay, this is going to cost you like $20 an hour. And then they just said that, okay, a person is actually cheaper than that.
I mean, it is a problem, but there is a spread. So OpenAI at the top end of the spread. Ultravox is down towards the bottom end of the spread if you go and look at it. And some of the newer stuff, Gemini and Nova Sonic, I can't even work out what they're being sold for because I've never managed to be charged for anything. But I think they're quite low, but they're not. Yeah, they need a bit of work to get to the point. So I think it is coming down. And when Simon was saying yesterday, my question to him again was, if you're taking the real-time tokens and you've only got $1 an hour of revenue, how's that working? But I think that is going to get better over time, particularly if you don't need a very capable model. I mean, Ultravox is Llama 70B, and if you do the right tools calls and the right prompting, so you keep everything small and you keep the context tight, you can build some quite creditable agents with that.
I didn't have a follow-up question very, very quickly. So I also noticed that one of the key things is tool calling, right? That's how you add the intelligence to the model. So how do you keep latency down when you have the tool calls, right? Because you need to grab to an external system.
Yeah, I mean, you just explain what you're doing before you do it. How's that any different to a human call center operative where you say, can you tell me what my balance is? And the human says, click, 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 just a minute. Same sort of thing. And you'll notice in that quick demo, the agent said, I'm passing you over. And because that was a prompt I threw up last night after the boat party, it didn't actually do anything useful, like say, hold on a minute, I'm doing that. But that's how you would architect. And a lot of that fine-tuning, the whole customer experience, a lot of it is in that fine-tuning and figure stuff out. And there's a whole load of stuff that I've not talked to on input accuracy. So if you're doing things like taking email addresses and phone numbers direct from LLM input, it generally doesn't go very well. So you need to get some out-of-band metadata if you possibly can.
All right. I think that will be it. Thank you very much, Rob.